Hi students, you are welcome to my class. Please consider going through the first examples down to example 4 before coming to this for a better understanding. So today, moving from where we stop, we're going to look at these two examples and probably call it a day for calculation on linear expansivity. If along the line there is problem, please ensure you contact me for better explanation. So looking at this, a brass rod is 2 meters long at a certain temperature. What is the length for a temperature rise of 100 Kelvin if the expansivity of brass is 18 by minus 6 per Kelvin? As usual, the first thing you do is to identify your parameters. A brass rod is this. Here is going to be my original length. At a certain temperature of which we don't know, it might be a little bit above room temperature, as the case may be. What is the length for a temperature change of this? Here is change in theta, meaning that your theta 2 minus theta 1 has already been given to you. So the length you are looking for in this case is not change in length. Please take note. This is different from what? From the previous questions. Here you are looking for what? L2. The final length after it has been heated through a temperature rise of what? 100 Kelvin. Are we clear? So if you have your alpha to be this. Now, solution. What are the known? So we have our L0, the original length before heated, to be 2 meters. We have the temperature rise to be 100 Kelvin. Then we have the coefficients of linear expansivity of the material to be what? 18 times 10 raised to power minus 6 per Kelvin. Now, what is the unknown? Unknown is what? The final length. Final length, which is L2. Now, remember, there's a formula. Before that, recall your general formula, which is what? Alpha is equal to L2 minus L0 all over L0 theta 2 minus theta 1, which is same as what? Change in temperature. Remember, I gave you a formula like this in case you're looking for what? L2. It is gotten from what? Making L2 subject of the formula from this one, which is equal to L0 into 1 plus alpha change in theta. So this one is the easiest. Quickly use it, especially if it is objective. It's fast for you to do and get your answer fast. So hence I can have L2 is equal to, what is my L0? The original length, 2 into 1 plus, what is alpha? Is 18 times 10 raised to power minus 6 times what? Temperature rise is what? 100. So you see that it's very fast. By the time I multiply what is here, I have 18 exponential minus 6 times 10 raised to power minus 6 multiplied by what? This to give us what? Then plus what? Plus 1. That will give us, you have your 2 into 1.0018. Then when you multiply it through by 2, so you end up having 2.0036 meter. So that is your what? L2. The question can go further to ask you what is the extension. What do you do? Remember, your extension is the same thing as what? Change in length. So your extension E, which is the same thing as what? Change in length, is equal to L2 minus L1. So what is my L2? L2 is gotten to be 2.0036 minus L0. So some textbook make use of L1 as the original length. So L0 is what? 2. So by the time I subtract this from here, I'm going to have 0.0036 meter as the change in length or the amount of extension after it has been subjected to heat. Are we together? That is all about this type of question. Now let's quickly look at example 6, which says the ratio of the coefficient of linear expansion of two metals, alpha 1 all over alpha 2 is 3:4. If when heated through the same temperature change, the ratio of the increase in length of the two metals, E1 over E2, remember increase in length is taken as extension, which I have already shown here, is ratio 1:2. Calculate the ratio of the original length, L1 over L2. Permit me to erase this. I believe you have understood this. So quickly in this, you are given that alpha 1 for the first metal to the ratio of alpha 2 linear expansion of the second metal is equal to 3:4. Remember, in your elementary maths, they said ratio is a form of fraction, which implies that alpha 1 all over alpha 2 is the same thing as saying 3/4, which in that case, alpha 1 is same as 3 and alpha 2 is same as what? 4, comparing the two ratios. In that case, I can say that alpha 1 is equal to 3, right? And alpha 2 is equal to 4. In the same vein, the extension E1 to extension E2 of the second metal is equal to 1/2 because the ratio is 1:2, which implies that E1 is equal to 1 and E2 is equal to what? 2. If this is done, then you quote your formula. Recall the formula that alpha is equal to extension, which is change in length, all over what? L0, right? Into what? Change in theta. Now, remember that the question says that if when heated through the same temperature change, what is this statement implies? It shows that they are heated through the same temperature. That is, change in temperature for metal 1 is the same as the change in temperature for what? Metal 2. Is that clear? Now, if that is the case, it shows that change in temperature for metal 1, I will use subscript 1, is equal to change in temperature for metal 2, which I can say is the same thing as what? Theta. So from this general formula, I'm going to write it for metal 1. I'll write it for what? Metal 2. So for metal 1, I'll have alpha 1 is equal to E1 all over. The original length for metal 1 is what? L1. Since the change in temperature for metal 1 is the same as that of metal 2 and is equal to theta, I'll just write theta here. Is that clear? So, which I can call this as my equation 1. Then I'll write for metal 2. Here will be alpha 2 is equal to E2 all over. The original length for metal 2 is L2. Then the change in temperature is the same, theta, theta. I can call this equation 2. Now, in order for me to get the ratio, right? In order for me to get the ratio, or possibly there are many ways you can apply this. As simple as it is here, I might just substitute the values. If I do that, I'm going to have for equation 1, alpha 1 is what? 3 is equal to E1 is 1 all over L1 theta. From here, I'll make L1 subject of the formula, which implies 3 times this. I'm going to have 3 L1 theta is equal to what? 1. I just cross multiply. So from where L1 is equal to, by dividing both sides by what? 3 theta, I have 1 all over 3 theta. I have my L1. So from equation 2, alpha 2 is what? 4, which is equal to E2 is what? 2 all over L2, that is what I'm looking for, L2, then theta 2. I make L2 subject of the formula, cross multiply, which implies that L2 is equal to 4 times L2 theta. Let me do it. 4 L2 theta multiplied by what? 4 is equal to what? 1 times 2 to give me what? 2. In that case, I have L2 is equal to what? Divide both sides by 4 theta. I'm going to have 2 all over 4 theta. By the time 2 here, 1, 2 here, 2, that will give us 1 all over what? 2 theta. So I have my L2 is equal to this, and I have my L1 is equal to this. Remember, the question is asking us to calculate the ratio of the original length L1 to L2. So L1 all over L2 will be equal to, what is my L1? 1 all over theta, 1 over 3 theta. Then big division all over. L2 is 1 all over 2 theta. Now this is division of fraction by fraction, which is equal to 1 over 3 theta. This big division will turn to multiplication and it will reciprocate. Here will now become the numerator, here will become what? Denominator. I have 2 theta all over 1. Now theta will now cancel theta. I have 1 times 2 to give me what? 2 all over what? 3 times 1 to give me what? 3. Therefore, L1 to L2 is same thing as 2 ratio 3. That is how to approach this type of what? Question.